Hey guys, so let's take a look at Chapter 12, problem number 13. A 15-meter uniform ladder weighing 500 newtons rests against a frictionless wall. The ladder makes a 60-degree angle with the horizontal. A. Find the horizontal and vertical forces the ground exerts on the base of the ladder when an 800-newton firefighter is 4 meters from the bottom. B. If the ladder is just on the verge of slipping when the firefighter is 9 meters up, what is the coefficient of static friction between ladder and ground? So now let's identify the givens. It's given that the length of the ladder is 15 meters. It's also given that the force pushing down into the ground of the ladder is 500 newtons. The ladder is leaning against the wall at a 60-degree angle. The force of the man pushing down is 800 newtons, and the man is 4 meters up the ladder. Now let's identify the find. In part A, they want us to find the forces in the x direction and the forces in the y direction. In part B, they want us to find the coefficient, or mu, of static friction. If we take a look at figure P 12.13, we see that there is a force of friction pushing towards the positive direction of the ladder. The thing that is keeping the ladder in place is the normal force of the wall pushing in the negative direction. The ladder is also pushing down 500 newtons, as well as the man pushing down 800 newtons. What's keeping the ladder in place is the normal force of the ground, which is pushing up. Now we need to find equations. The sum of friction or force in the x direction is equal to the friction of the ladder minus the normal force of the wall. And this is equal to 0 because the ladder is not moving left or right. Likewise, the sum of the forces in the y direction are equal to the normal force of the ground. What's acting against that force are the 800 newtons of the man and the 500 newtons of the ladder. And because the ladder is not moving up or down, this is also equal to 0. Now we need to find the sum of the torques about the axis. That equation is equal to negative m1g, or the force of 1, and the length divided by 2, multiplied by cosine theta. You subtract this from the mass of the second times the second acceleration, and then also by its angle. Finally, continuing with this equation, you will add the normal weight, normal force of the wall, times its actual length multiplied by sine theta. And because the ladder is not in motion, this whole equation is equal to 0. Now what's left to do is to take the givens and plug them into the equation, and then rearrange for the normal force of the wall. The normal force of the wall, when all is said and done, is going to be equal to 4 meters multiplied by 800 newtons plus 7.5 meters multiplied by 500 newtons. And all of this is going to be divided by 15 meters. And then finally, because you had a sine divided by a cosine in your rearrangement, you will multiply the numerator by a tangent 30 degrees. With some basic algebra, you can find that the normal force of the wall is equal to 268 newtons. Now, we plug this back into our original equations. The sum of force in the x direction was friction minus the normal force of the wall, and that was equal to 0. Because the normal force of the wall is equal to 0, we know that friction is equal to 268 newtons. So therefore, the sum of the forces in the x direction is 268 newtons. The sum of the forces in the y direction was the normal force minus 800 newtons minus 500 newtons. To rearrange for that, we find that negative 800 newtons added to negative 500 newtons is negative 1300 newtons. Add this to the normal force of the ground. When you rearrange, you'll find the normal force of the ground is equal to 1300 newtons. This is also considered the sum of the forces in the y direction. Therefore, your answer for this set is 1300 newtons. So now let's take a look at B. They want to know the value of the static friction as the ladder is about to slip. From this, the sum of the torque about the axis we can assume is 0. Because of this, we can now plug into our equation the new 9 meters that the firefighter is now up the ladder, multiplied by his 800 newtons, also multiplied by sine of 30 degrees. This is added to 7.5 meters of the ladder times 500 newtons times the sine of 30 degrees. And this is subtracted by 15 meters multiplied by the normal force of the wall times the sine of 60 degrees. And this whole equation, because it is the equation of the sum of the torque about the axis, is equal to 0. Now with some simple algebra, you can find that the normal force of the wall is equal to 421 newtons. And because the friction is equal to the normal force of the wall, which is equal to 421 newtons, we assume that the friction is at its maximum point. This is also equal to mu multiplied by the normal force of the ground. Using the equation, we can find that mu is equal to the maximum friction divided by the normal force of the ground. Taking the normal force of the ground that we found in part A as 1,300 newtons, and dividing it by what we found in part B, 421 newtons, we find that the coefficient of friction is 0.324. And because the units cancel out, this has no unit.